Hello students, once again, you are welcome to Waidsum Academy. Today we will be looking at 3D shapes in mensuration, a topic called mensuration. And mensuration is wide. We have mensuration for 2D shapes, like areas and perimeters of shapes. And then we have mensurations for 3D. So today we're focusing on mensuration for 3D shapes. For 2D shapes are easy. Area of triangle is half base times height. Area of a rectangle is length times width. So we already know all of this. Okay, we've done them in our previous classes. Area of circle is pi r square. Circumference of a circle is 2 pi r. We've done all of this before. We know all of this for 2D shapes. But today we're going to learn the mensuration in 3D shapes, and we're taking the first one called the cuboid. We're taking the first aspect of mensuration in 3D shapes, and we're starting with cuboid. Now, the first thing we're going to learn to do with a cuboid, the shape you see here is a cuboid. Now, the first thing we're going to learn to do in a cuboid is to calculate the volume of a cuboid. To calculate the volume. So volume, as it were, is length times width. If this is the length, let's say this is our length, L, okay, L equals to 10 centimeter or 10 whatever, and this is the height, H, equal to 5, and this is the width. The width is equals to 7. So we have all of these sides of a cuboid that is given to us. Now, the first question is calculate the volume of the cuboid. So the first question, question number 1, A, say calculate the volume of the cuboid. Calculate the volume, so I write VOL, the volume of a cuboid, of the cuboid. Okay, so we're going to find the volume of this cuboid. So volume is easy. But before we come to the B part of this question, the B part is to calculate the total surface area of the cuboid. Now the volume is easy because volume is length times width times height. As simple as that. The volume of a 3D shape is simply the length. If it's a cube, we say length times length times length because all sides are equal. So but for cuboid, we say length times width times height. Length times width times height. That will give us the volume of this cuboid. So the volume V is equal to the length, which is 10 centimeter. The length, which is 10 centimeter, or 10 multiplied by the width, which is 7, multiplied by the height, which is 5. Okay? So this will give us the volume. 7 times 5 we get 35, right? So 35 times 10 we get 350. So our volume will be equal to 350 centimeter cube. 350 centimeter cube if the units are in centimeter. If the units are in meter, you say 350 meter cube. If the units are in feet, 350 feet cube or cubic feet. Okay, so that's the volume. The A part of the question say calculate the volume of the cuboid. So to calculate volume is simply the length times the width times the height. Okay, so I think this is clear enough. Now we go to the B part of this question, which says that we should calculate the total surface area of the cuboid. Calculate the total surface area, total TSA, total surface area of the cuboid. Calculate the total surface area of the cuboid. For a 3D shape, such as this cuboid, we're going to write the formula for calculating the total surface area. Because this shape, okay, calculate the total surface area of the cuboid. So no need for me to write of the cuboid. I just write calculate the total surface area. Okay, you can see this one has a top and a bottom face. So, and they're same. Both the top and the bottom face, they're same. So if I calculate the area of this face, of this top face, I'll just multiply the answer by 2 in order to get this, the top and bottom. Okay. So here we have 6 faces. We have the top face. We have plus the bottom face. The one that are similar, I'll put them together in group. Top face and bottom face. Okay, we have the top face and the bottom face. That's one. I will do, when you're doing, if you do the top, just multiply the answer by 2 because it's same. The top face and the bottom face, they are equal. They are equal. Okay, another similar faces is the front of the cuboid and the back. So this one, once you calculate the front face, you just multiply your answer by 2 you get for front and back. Okay, front face and back face. Front face and back face. This is the front face, this one. The back face is this corresponding one here. Okay, remember it's a 3D. It's just like your refrigerator in the house, it's a 3D shape. The front of the refrigerator and the back side of the refrigerator. Okay, well, that's what we are saying. So if you do the front, multiply the answer by 2, it will represent front and back. If you do the top of your refrigerator and multiply the answer by 2 to be for the top and the bottom face of the refrigerator. And then we have 2 sides. So sides. A side plus a side of your refrigerator. The right side, so we can say arrow side and left side. Arrow side plus left L side. So we have sides of the refrigerator. So once you do one side, you multiply the answer by 2. Then we add everything together. We add everything together in order to get the total surface area of the cuboid. Okay, so now let's begin to generate. Let's begin to generate. The top face, you can see is length times what? Width. You can see length. This is the length for the top cover. The top cover. You can see length. Not only your refrigerator in the house, your TV stand is a cuboid. We have vertical cuboid like your refrigerator. We have horizontal cuboid like your TV stand. Most of your TV stand, okay? Okay, so they are cuboid. Your box, they are cuboid. Okay, they have cubic shape. So some are cube if they are equal, both the length and the width and the height. If they are equal, then they are same. Like small refrigerator, very small refrigerator, or like the deep freezer part of it, they're usually the cube. If you cut it out, to be like a cube. If you cut from the deep freezer up or the deep freezer down, you see usually some of them are cube. Okay. So now how do we do the top? The top is length multiplied by the width. The top multiplied by the width, that's the area of the top. The area of the top. So we write that formula, top plus bottom, okay? Plus bottom. We write for top, which is length times width. Then because it's top and bottom, we multiply by 2. We are multiplying by 2 because it's two faces that we are talking about, the top face and the bottom face. Okay, like I said, because they are equal, it's like saying length times width plus another length times width. So instead of doing that, you just say multiply the answer by 2. So our length is 10. Our length is what? 10. Times our width is what? 7, right? Our width is 7. If we go back to the diagram, this is the width. This one is equal to this one, you know, right? They're equal. So it's 7. So our width is 7. So you multiply, you get 70. If we multiply, we get 70. Then 70 times 2, 10 times 7 is 70. Multiply by 2, we get 140. So for top and bottom, this 140 is for top and bottom. Top and bottom, 140 centimeters square. Because we are doing area, so it's square, it's not volume. See, if they're in centimeters, you say 140 centimeters square. For top and bottom, for only top is 70. Only top is what? 70. For only top, your answer will be 70 centimeters square. For only top. But because we are doing top and bottom, two sides, the faces, corresponding side or the opposite sides are equal. Okay, so our answer we're looking for top and bottom is 140. Now let's do for the sides, the front and the back sides. The front and the back. Here is the front one. It's also length, but the other side is called the height. Okay? Because this is the front. It's length multiplied by the height. So for front and back, this is segment 1. We can call here segment A. This is segment A. This one now is segment B. Front and back. Front, plus back, plus the back side. So no need to be doing for the back, just do only for the front. You multiply your answer by 2. Do only for the front, and then you multiply your answer by 2. So the front is length multiplied by what? By height. The length multiplied by height. So we multiply the answer by 2 in order to get for front and back. So we say this is our length is 10 and our height is 5. Our height is 5. Okay? So if that's 50 for only front, 50 centimeter cube for the area of the front. Because we're looking for front and back, we multiply the answer by 2. We get 50 times 2, we get 100, right? So we say 100 centimeters square. 100 centimeters square. That's the area. That's the area of top and bottom. That would be the area of the top and the bottom part. So 100 centimeters square will be the area, sorry I said top and bottom, area of the front and back side. That will be the area of the front and back side. So we've done for top and bottom, we've done for front and back. Now let's do for the left side and the right side. So the third segment, we can call this one, instead of saying A and B, because this is actually question B, we call this one Roman figure 1. Why we call this one Roman figure 2? Roman figure 2, not A and B again. Why we call this third one Roman figure 3? So we say the right side, arrow side, plus the left side. Let's find the area of this side plus the left side. So when you find the area of this side, once you find the area of arrow side, you multiply the answer by 2. Now let's go to the diagram and see the sides. These are the sides this way. This one is the face of the side this way. is the face of the side, and this is the face of the other side. Okay, so the sides are width times height, width times height, or height times width, width times height, width multiplied by height. So once you do this, you multiply the answer by 2 you get for both right and left side. Okay, so the width is 7 multiplied by the side, multiplied by the height, which is 5, you get 35, right? 35 times 2, you get 70. 35 multiplied by 2, you get 70. So for the sides, you get the area of both sides, both the left and the right side, total area to be 70. Now, the TSA, which is total surface area, the total surface area, what they ask us to calculate in this B part of the question, TSA, total surface area, is equals to the area of top and bottom, which is 140, area of top and bottom, which is 140, plus the area of the front and back, the front side and the back side, which is 100, plus the area of the two sides, the left side and the right side, which is 70. So we add these three together, we get the total surface area. Okay, remember this one is for top and bottom, this one is for front side and the back side, and this one is for the two sides, the left and the right sides. So we add 140 plus 100, that's 240. So 240 plus 70, 240 plus 70, what do we get? $240 plus 70, 310, right? We get 310? Yep. So we get 310. Total surface area is equal to 310 centimeter square, not cube. Remember, this is about area. Okay, this is about area. 310 centimeter square, not centimeter cube. Only volume you write cube. Only for volume we write cube. Okay, so that's that for this question. If the question gives us a cuboid and asks us to find the volume and also asks us to find the total surface area. Now before I move on, let's take a cube. In the case of a cube, it's easier. Problem is easier. Question number 2. If this was a cube, all sides would be equal. If this was a cube, let's say this is a cube. If this is a cube, if this is a cube, all the sides will be equal. Question number 2. You know a cube, right? We know what is a cube, right? Presumably all sides are equal. Okay? Even if our drawing is not perfect, let's just assume all the sides are equal. Let's say I have 5. So if here is 5, here will be 5, the width will be 5, and the height will be 5. Okay? So for a cube, this is for cube. Question number 2. Calculate the volume of the cube. Let's change because we're doing something different now. This is for cube. So this is a cube. They ask us to calculate the volume of the cube, the first question. Question 2a. Calculate the volume of a cube. Question 2a. Calculate the volume, okay? Volume. Okay, volume is length times length. Why am I saying length times length times length? Because the width is equal to the length and the height is equal to the length. So they're equal. Also, you see the value 5, 5, 5. So the one you call the width is same as the length. The one you call the height is same as the length. So it's like you say the volume is length raised to power 3. Is length raised to power 3. So the volume can simply, for a cube, you can simply say V is equals to L to the power of 3. Even if you don't say L to the power of 3, you just say length times width times height, you still go to say 5 times 5 times 5. Okay, so you go to say 5 times 5 times 5 in EDC is the same as 5 to the power of 3, which is 5 times 5 times 5. So if you multiply 5 by 5, you get 25, times another 5, you get 125, right? So if we do this, we get the volume to be 125. We get the volume to be 125 of this cube, 125 centimeter cube. This is the volume of this cube. Now what about the total surface area? The B part of the question. If the B part of the question says we should calculate the total surface area of this cube. Now all the faces are same. So we can just do one face and multiply the answer by 6. If you are not paying attention, you're a big Google, because I'm teaching you something you need in your exams. Okay? Now, for cube, you don't need to do the top and bottom, front face, side, right side, left side, and the front and back side. No. For cube, just do one face. All the 6 faces are same. So the area of one face, you multiply the answer by 6, because there are 6 faces. Just do the area of one face and multiply the answer by 6. So we're going to say the area of the top face, assuming this is the top face, we find the area of the top face. Here is 5 and here is 5. So area of the top face is equal to 5 times 5, or length times length, whatever you want to call it, because they are equal. 5 times 5, which is 25. Which is 25, right? We get the area of the top face to be 25. Now what is the TSA, total surface area? Total surface area will be equal to, because the whole 6 faces are equal, they are same, we will say 6 multiplied by 25. 6 multiplied by 25. We'll get the total surface area. So we can do that multiplication. 25 times 6. 25 times 6. We can do that multiplication and see what we find. So 5 times 6, 30, right? 0 carry 3. 5 times this, 6 times 2, 12. 12 plus 3, 15. So we get 150. So the total surface area of this cube is 150. So you can write 150 centimeter cube. So, centimeter square. Because we're talking about area. 150 centimeters. So the total surface area is 150 centimeters square. The total surface area is 150 centimeters square. Okay, that's, you can see for cube to find the total surface area is much easier than to find that of a cuboid. Because for cuboid, only 2 opposite faces are same. So you have to solve for those 2 faces first, and then you add all the faces. Okay, so that's that for cuboid. That's that for cuboid. Now let's see if we can do cylinder. A cylinder. If the height of a cylinder is 7 centimeters and the radius of the circle of its circular top is 3 centimeters, calculate the surface area of the cylinder. calculate the surface area. Okay, for a cylinder, before we do both the surface area and the volume, so we have to look at the volume of a cylinder and the surface area of a cylinder. We have to look at the volume of, so the next one we're looking at now is a cylinder. So we go to a cylinder. Let's change our color. Cylinder. So if we give you a cylinder like a drum, cylinder is like a drum. If you have a drum for fetching water, or you have some pipe, pipes like oil pipes, big pipe, PVC pipes, they are cylindrical in nature, right? Like drums, they are cylindrical in nature. So this is a cylinder. This is the top cover of a cylinder. This is the top cover of a cylinder. This body is not like a straight body. This body is not like a straight body, okay? It's a curved body. Okay, this is a cylinder. This is a sample of a cylinder, okay? Now, here is a circular top and circular bottom. The top and the bottom, they are a circle, okay? While you have the height of the cylinder. We have the height here, h. We have the height of the cylinder, and this is the radius of the circular top, radius of any circular part. So the first thing we do is how do we calculate the volume of a cylinder and how do we calculate the surface area of a cylinder? How do we calculate the volume of a cylinder? Every 3D shapes, you must learn how to calculate the volume of that 3D shape and the formula for calculating the total surface area of that 3D shape. Okay, so for this cylinder, the volume is equal to pi r square h. Pi r square h. Why? Why is this so? Why is our volume equal to pi r square h of a cylinder? Okay, the reason is that the base area or the area, volume is area times height. Volume is always area, V is always area times height. Or V is length times width times height. Even if you write V to be length times width times height, it's still same as area times height. Even if you write LWH, it's the same as area times height, because length times width is area. This length times width represent this area. Length times width represent the area. Area is length times width. So it's like when you say volume is area times height, it's same as length times width times height. Is that okay? These are for different shape, but for circle, area is pi r square for circle. Okay, that area covers this pi r square. In a circle, you remember the cylinder, the top or the bottom is a circular shape. So area of a circle is pi r square. You remember that? Area of a circle, we've done that before. Area of a circle is pi r square. So for cylinder, to calculate the volume of a cylinder, you say the area of this circular part multiplied by the height, you get the volume of the cylinder. Area of this circular part multiplied by this height, you get the volume of this cylinder. So that's what this is. So let's say, for example, we have some numbers. Let's say like we have 3 centimeter and 7 for the height. We have 3 centimeter here for our radius. The radius of this circle is 3 centimeter, and then this height is 7. Calculate the volume of this cylinder. before we looked at the total surface area of the cylinder. Now let's calculate the volume of the cylinder. So the volume, like we said, is pi r squared times height. So the pi is, we can take 3.14 for pi, 3.142 or 3.14, okay, times the radius, which is 3. Remember, we're going to square the 3. We're going to square the 3 because of this formula, r squared. Not just times 3 squared, okay, then times the height. The height has been given to be 7. We multiply by 7, okay. So when you do that, we can evaluate the volume of the cylinder. Okay, can someone multiply for us? 3.142, 3.142. 3 squared is 9 times 9. That's 3 times 3 is 9 times 9 times 7. So what will be the volume of this cylinder? 197.82, right? So we get the volume of this cylinder to be 197.82. So we get the volume of this cylinder to be 197.82 centimeter. If they are given in centimeter, you say centimeter cube. If they are given in meter, you say meter cube. If they are given in feet, you say cubic feet or feet cube. So that's that for the volume. Now what do we do? What else can we calculate? They can ask us to calculate the surface area, okay, and we should know the formula for the total surface area. Okay, we should know the formula for the total surface area. Now let's take a look at the formula for the total surface area. 2 pi r squared plus 2 pi ROH. Now let's take the formula for the total surface area. Okay. Now the total surface area, which is the B part of this question, is to calculate the total surface area of this. Calculate the total surface area of this cylinder. Calculate the total surface area of the cylinder. Now, what's the total surface area of a cylinder? The formula, TSA of a cylinder. Now, the total surface area, we're going to look at how we come about that. It's equal to 2 pi r squared, 2 pi r squared plus 2 pi ROH. 2 pi ROH. Okay, so this is the formula for the total surface area. Why? First of all, let's explain this 2 pi r squared. How do we get this 2 pi r squared? You can factorize this. You can simplify this. And I will come to that. How we factorize this and reduce the formula. Okay. Now, because there are two, total surface area, you must calculate area of any face that is given to you. There are two circular face. So the area of one circle is pi r squared. Since there are two circles, the area of one circle, there are two circles, the top one and the bottom one. For a cylinder. For every cylinder, there are two circular parts. And the area of this one is pi r squared. So multiply by 2. Since there are 2, multiply by 2, it becomes 2 pi r squared. That's how we got this 2 pi r squared from this part of this formula. Because here is pi r square plus pi r square. If you add pi r square plus pi r square, you get 2 pi r square. Either you say add this pi r square plus pi r square, you get 2 pi r square. Or you just say, since there are 2, you just say this pi r square times 2. Times 2, it becomes 2 pi r square. You get that? So I've explained how we got this first part of the total surface area of the cylinder. Now this part, they are curved. They are not like a straight line. They are not really a straight line. Take a look at a drum. The body is curved. The body of a drum, of a cylindrical drum, is curved. Despite we use line to represent it, it's not line, it's circular. It's circular. You take a water bottle. The body is circular. The body is circular. Okay? It's not like line. So when we say cylinder, even for drawing, that's why the only way we can show the drawing is to show line. It's to show line. But for the reality, real life, the body of the water drum, the water can, is cylindrical, is curved. So the body itself is like a circumference, a big circumference. You understand? The body is like a circumference. So if you spread it out, let's say we cut the water bottle. If we spread it out, we will get what? If you cut it, if you take a knife and you cut it and spread it out, this curved body, this body is curved. This body is curved. This curved body will form a rectangle. If you cut it and stretch it out, it will form what? A rectangle. It will form something like this. It will form something like this curved body. This curved body will form a rectangle. Okay? This is still the height of the rectangle. While this one is the circumference, the big circumference that you spread out. And remember, circumference is 2 pi r. This length, this one you call the length, is actually the circumference. This length is the circumference, which is 2 pi r. So if you cut it, if you cut this one, you spread it out, this body that forms the length, because if you cut it and you spread it out, it forms a rectangle. It forms a rectangle. How long it is actually the circumference, the circular part. It's actually how circular it was. If the circular nature was small, the length will be small if you spread it out. If it was wide, the length will be longer, depending on how long the circular cylindrical shape was before. So that's how we got. And you know the area of this rectangular part is length times height in this case. So when we find the area, you get 2 pi r h. That's how we got 2 pi r h for the cylindrical curved part, the cylindrical curved part. So I hope you understand now why the total surface area formula for a cylinder is 2 pi r square, which is from the two circles, the top and the bottom circle. The circular part, the curved part, you spread it out. When you cut it, it becomes the circular part. Now this circular part, this curved body part, forms the length, which is now our 2 pi r. Multiplied by the height, this height, multiplied by the height, you get 2 pi r h. This is how we got this formula, 2 pi r h. And how we got this 2 pi r square is these two circles, the top and the bottom, we added together, we get 2 pi r squared. So this is the formula for calculating the total surface area of a cylinder. This formula we can factorize. How to factorize? You find what is common between this and this. To factorize, you have 2 pi r, you take it out, because there's 2 pi r here, there's 2 pi r here. So you take it out, what is common between this and this. So what remains here if you take 2 pi r? it remains only R. If you take 2 pi R out, only R remains here. Plus, what remains here? If you take 2 pi R out, only H remains here. So you say plus H. So this formula can be reduced like this, the TSA, the total surface area. In case you see the total surface area in the textbook, like this, okay, this is how it came about of a cylinder. Okay, this is how the formula came about. The total surface area of a cylinder is 2 pi R into R plus H. Now, if we are asked to find the total surface area, we can just substitute the value into this formula, which means we can write 2, to calculate this, we can just write 2 times 3.14, which is the value of the pi. 3.14 into the radius. The radius was what? Oh, before the radius, wait. Before the radius, we have to multiply by radius, right? Before this radius inside, there's a radius outside. So we have to multiply by this radius outside. And the radius is 3 centimeters. Remember from the question. So we multiply by 3. Before we open the bracket, what's the radius? Is also 3. You say 3 plus, what's the height? Height was 7. So 3 plus 7 is 10. Okay, so what is inside the bracket is 10. 3 plus 7 is 10. So you say 10. Multiply by, let's multiply this one. 2 times 3.14, that's 6.288284 times 3. What do you get? Multiply this one. What do you get? What do you get? 2 times this times 3. What do you get? Quickly. And the answer we get here, we will multiply it by 10. 2 times 3.14. 2 times 3.14 times 3, what do you get? 18.852, right? So we get 18.852. So that multiplied by 10, you will get 188.52. Because if you multiply anything by 10, you have to shift the decimal once. So this becomes 188.52 centimeters square. So this becomes the total surface area of the cylinder. This becomes the total surface area of the cylinder. So in our today's class, we've taken two 2D shapes. We've solved cylinder. We've taken 3 actually. We did cuboid, we did cube, and we did the cylinder. So we will be stopping today here for this class. Our next class we're going to do prism, pyramid, okay? And then the third one class will be sphere, cone, and so on and so forth. So we round up this topic, 3D shapes, mensuration in 3D shape with 3 classes. Okay, so today we will be coming to the end of this section, and we thank you for joining our class. Thank you.